This meeting is being recorded.
Yeah, hello everyone. Is my voice audible, guys? So in last session, we have discussed about scopes in JavaScript, and we discussed about scope statements in JavaScript. So we had a discussion on scope statements like var, let, and const. Okay. Apart from that, we have discussed what are the different scopes like global scope, what is function scope, and what is block scope. So this is what we have discussed in the last class. Now in today's session, let's understand what is lexical scope. Okay, today's agenda. Then let's discuss what is closures. Before that, we have to discuss about lexical environment. Then we have to discuss about object. So object concept, and if possible, we will discuss operations on object. This is what we are going to discuss in today's session. So all these are advanced concepts, guys. These are not basic concepts of your JavaScript. All these are the advanced concepts of JavaScript. Now, if you know all these concepts, it becomes very easy for us to understand the high level technologies like React or your Node.js, even Express, even MongoDB, and it will help us to build an application as well. So whatever topics I am covering right now, all these topics are explained to a people who have experience minimum 3 years or 2 years. Minimum 2 to 3 years of experience you should have. Then only you will be able to understand these concepts. And even if you go for interviews, the people who is having 2 to 3 years of experience, those people will be asked questions on these topics. Generally for freshers, they won't ask much about this. Okay, so let's understand what are what is lexical scope, what is lexical environment, what is closures, what is object, operation on object. So before I start today's session, let's understand what we have learned in last class. So in last class, we have discussed about scopes. Now scopes are nothing but it defines accessibility. Defines accessibility. It defines the accessibility. Nothing but, or you can say, it defines the area where something can be accessible. And we have seen that in JavaScript, we have basically three scopes: global scope, function scope, and block scope. So scopes are nothing but you can call it as accessibility, defines accessibility, or it defines area where something can be accessible. So if you have a JavaScript file, let's assume that this is your JavaScript file. Now inside this JavaScript file, any area which is not under any block, that area is called global scope. Right now, let's assume that this is JavaScript file, then this entire area is called global scope, or we can call it as a global area. So if I open my Visual Studio Code, let me just open a folder. Now let's create one simple JavaScript file here. I'm creating a file called scope.js. Scope.js. Now this is JavaScript file. So it is starting here until here it is the entire JavaScript file. Now this area is called global scope because this area is not under any block. Now suppose here if I create a function f1, then this area which is inside the function, this area is called function scope. And what is global scope? The area which is not under any block, means this area, this entire area is called global scope now. So this area comes under function scope. In the same way, inside this function scope, if you create any block, like if you create one if block, now this space which is inside if block, this space is called block scope. This is called block scope. This is called function scope, area which is under a function. So this entire area is called function scope. This area, this specific area is called block scope, and this area is called global scope. This is called global scope. So if you define something in global scope, for example, here I am defining one variable where x equals to 10. If you define something in global scope, or here instead of something, I will directly use the term variable. If you define a variable in global scope, then that variable you can access anywhere in global scope. Anywhere in global scope. So now this particular variable you can access anywhere in the global scope. Not only global scope, you can access that in the function scope also. If you want this variable, you can access here inside the function scope also. Anywhere you can access. Not only function scope, you can access that in the block scope also. So if you define a variable in a global scope, okay, remember this point. Defining variable in a global scope. Then that variable you can access anywhere. You can access in global scope. You can access in function scope. You can access even in the block scope. You can access even in the block scope. In the same way, if you define any variable in function scope, if you define any variable in function scope, if you define a variable in function scope means, now let's assume that this area is called function scope. I am defining here one variable where y equals to 99. Then this variable, then that variable you can access anywhere in function scope plus block scope. So that variable you can access anywhere in function scope plus block scope. But you can't access in global scope. You can't access in global scope. Suppose if I want to access this y variable here I want to use. No, you cannot access. So now this variable you can access anywhere inside this function scope plus you can access in the block scope. That's it. Next, if you define any variable in a block scope, if you define variable in block scope, in a block scope using var, then that variable you can access anywhere in function scope plus block scope, but you can't access in a global scope. If you define a variable in a block scope using var, remember, using var, this is very important, then that variable you can access anywhere in function scope plus block scope. Suppose this is my block scope. Now inside this block scope, if I am creating a variable with var equals to z, and here I am adding 10, then now this variable you can access in this block scope plus you can access even in the function scope. Even in the function scope you can access. But in the same way, if you define a variable in block scope using let or const, then that variable you can access anywhere only in block scope. But you cannot access in global scope, plus you cannot access in outside the block scope. Now outside the block scope can be function scope or any other block scope. This is very, 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 very important. Especially these 2 points you have to properly understand. So if I create any variable with let, if I say c equals to 1, if I say const pin equals to 1, 2, 3. Now these 2 variables you can access only inside this block scope. You cannot access here you cannot access, even outside you cannot access. But if you create variable with z inside a block, then that variable you can access even inside this block, even you can access outside the block, but within the function. This is what you have to remember. This is what we have discussed in the last class. Now, what is this lexical scope now? What is this lexical scope? Lexical scope is nothing but current function scope plus its outer function scope plus global scope. That is what we are going to call as a lexical scope. Lexical scope is nothing but current function scope plus its outer function scope plus global scope. If you try to understand in the terms of area, then like this, the current function area plus outer function area plus global area. That entire area from current function area to outer function area to global area is called lexical scope. Now let me show you practically. I am creating here one file called lexicalscope.js. Now this entire area is called global scope. Now here I am creating one function called function outer. Now this is function scope. Inside the function I am creating one more function, function inner. Now this space, this area is called scope of outer function. This area is called scope of inner function. Now what is lexical scope? Lexical scope is nothing but for this inner function, this particular area, its own area plus outer function area plus global area. This entire area, this global area, this outer function area and current function area. So that is the lexical scope for this function. So what is the lexical scope for outer function? For outer function, its own area plus global area. That is the lexical scope for this outer function. It means if you create any variable in global scope, that variable you can access in the inner function. Here you will be able to access anywhere you can access here. If you create any variable in outer function scope, now this variable also you can access anywhere inside this inner function scope. If you create any variable in inner function scope, now this variable also you can access anywhere here. So if I do here console.log of x, y, z. And now if I call here my inner function and if I call my outer function, now you will see that result will be printed in the terminal. So now this function having the access of its outer function scope, this function having the access of global scope also. So now if I run my code, lexicalscope.js, now see I got the result. Now how we got the result? Because inside this function scope, you can access the variables defined here, variables defined in outer function scope, variables defined in global scope also. Now let's assume with the we can assume by referring this particular function now. See here. Now for this outer function, its own scope, its own scope is called function scope. So it will have the access of its own scope plus it will have the access of global scope. But this outer function will not have any access of this inner scope. This outer function will not have any access to inner function scope. It means I cannot access Z. I cannot access Z here, or I cannot access here. Suppose here if I am calling like this, console.log of z, I will get the error because this is the area of outer function. So outer function doesn't have access to the inner function scope. So this variable z you defined in the inner function scope. So this variable access outer function will not have. Outer function will have access to its variable plus any variable defined in the global scope. So now here I can access x comma y. If I am accessing x comma y, I will get the result. I got the result. But if I try to access z, here if I try to access z, now where z is defined in the inner scope, inside the inner scope, inside the inner scope function. I am trying to access z inside the outer function scope. It won't allow. So if I try to run, I should get error now. I got here error. Z is not defined. Here I got reference error. See, it is saying that you cannot access. On line number 12, I got the error. So if you see here, on the line number 12, I got the error. Here I am getting the error. And it is pointing out that error also. See, it is pointing exactly Z. So what is lexical scope? Lexical scope is nothing but access of current function area plus its outer function area plus global area. So for this inner function, its current scope, current area plus its outer function area plus global area. For outer function, its area plus global area. But this outer function cannot access the area of inner function. But inner function can access the area of outer function. So people will ask, what is lexical scope? Then you can explain what is lexical scope in this way. So lexical scope is nothing but it defines the area. Lexical scope is nothing but it's the area of current function plus its outer function, nothing but its parent function plus global area. So that area together we are going to call as a lexical scope. So global area plus parent function area plus its own function area. That area together, all this area together, we are going to call as a lexical scope. Okay. So now we have understood what is lexical scope. Next, we have to understand what is lexical environment. Lexical environment technically is a data structure. It is a technically one data structure which maintains information of current scope plus lexical scope. It maintains the area of, or we can say it maintains the information of lexical scope. That's it in simple way, because lexical scope is nothing but current scope plus parent scope plus global scope. So what is lexical environment? Lexical environment is a data structure. It is a data structure which maintains information of lexical scope. Which maintains the information of lexical scope. Lexical scope is area, but that area's information is maintained in the lexical environment. It is maintained in the lexical environment. So as a developer, as a programmer, you will never have access to lexical scope. You cannot modify the lexical scope. You cannot create the lexical scope. Internally, it is created by your JavaScript engine. As a developer, you will never have access to lexical environment also. It is also maintained by JavaScript engine. We just need to understand the concept. How JavaScript engine is handling the things internally. So as a developer, can we maintain our own lexical environment? Can we create that lexical environment? Nothing but can we create that data structure? Can we maintain practically lexical scope information? No, we cannot do. That everything internally handled by JavaScript engine. That is the work of JavaScript engine. We just need to understand what is lexical scope, what is lexical environment. Now, why we have to understand lexical environment and lexical scope? Because of this closures concept. Now, this closures concept is completely dependent on this lexical scope and lexical environment. Now, to understand this, what is closure? We have to take one example. First, we have to get cleared with what is lexical scope, what is lexical environment. Lexical scope refers to area. Which area? Current area, outer function area, global area. What is lexical environment? It is one data structure which maintains that information. So for every function, they will have their own lexical environment. So for this function, for this inner function, lexical environment will maintain the information of this area, and global area. For this outer function will have its own lexical environment. So it will maintain this outer function area and global area information. Inner function lexical environment will maintain current function area information, outer function area information, global scope area information. For outer function, it will have its own lexical environment, which will maintain its own area plus its outside. For this outer function, there is no other parent. There is no parent function. Directly global scope is available. So it will maintain the global scope area information. Area information means what you defined in that area. It will maintain this variable information. It will maintain its own variable information. When I say that it is maintaining the information of scopes means what you defined in that scope, what variables you defined, what functions you defined, that functions, that variables, memory, address, it will remember. That is the reason here you are able to access this X, Y, and Z. How you are able to access here? When we call inner function, when we call this function will execute. So what this function will do, it will maintain one data structure. It will maintain like this one data structure. In that data structure, it will maintain its own variable. What is its own variable? Z. So it will maintain the Z information. Then it will maintain the information of its outer function, nothing but its parent function. So for this inner, who is the parent? Outer. So in outer, what you defined? Y. So it will maintain that reference also. It will maintain the reference of Y. Apart from that, you don't have anything. Then it will go to the global. What you have? X. So it will maintain the reference of X. So what is the value you have? 10. It will maintain like this. Now this is the lexical environment of inner function. Now, how the lexical environment of outer function will be there? Now for outer function also lexical environment will be created. lexical environment of outer function. It means outer function will remember its own variable, that is y. Plus it will remember its parent. But for outer function, there is no parent. Directly global scope is there. So it will remember the reference of this variable. Reference of x. So now, when you are trying to access, in inner function, when you are trying to access x, so it will check its lexical environment. X value is there. Yes, X value is there. So it will print that 10. Then it will check. Y value is there. Sorry, here. Y value is there. Yes. Y value is there. It will print. Then it will check. Z value is there. Yes. Z value is there. It will print. Now here you see. This is the scope of outer function. Now here it will check. Value of X is there in the lexical environment of outer function. Yes. Value of X is there. It will print 10. Then it will check Y. Then it will check Y information is there. Yes, Y information is also there. It will print. Then it will check Z. Z is there. Here Z information is not there. So it will say that Z is not defined. So that error we are getting. Z is not defined. Why Z is not defined? It is saying that in my lexical environment, there is no information of Z. Z is not defined here. Z information is not stored here. It is not defined here. That is what the error we are getting. So when I run this code, now see here it is saying that Z is not defined. Because in that lexical environment, there is no information of Z. That is the reason that error we are getting. And that error, see, exactly it is pointing at Z only. This is what lexical environment and lexical scope all about. Generally, people won't teach, guys. If they teach, you even won't understand what they are explaining. That is how people will teach this advanced concepts. Is it clear, guys? Understood? Anyone have any doubts up to here? Any doubts, guys? Okay. Now let's understand what is closures. Now to understand what is closures, let's take one simple task here. Let me create here one simple task. I am creating one JavaScript file. Now in this file, I am creating one function f1, or simply I will say function parent. Inside this function, I am creating variable x equals to 10. And here simply I am writing console.log of x. And I am calling here this function. So whenever I call this function, so for this function, lexical environment will be created. So here lexical environment will be created. Who will create? Internally JavaScript engine will create. It is so fast we cannot realize as well. So internally lexical environment will be created by JavaScript. And in this it will maintain the information of current variable. What is the current variable? X. So it will maintain that X information. Then it will maintain the information of its parent. So for parent, there is no parent. And in global also, there is no variable. So nothing is available. Now, when you execute this line, console.log of x, Now your JavaScript engine will go and check the lexical environment. Is there value of x? Is x is present or not? If yes, then what is the value? 10. So it will access that 10 and it will print. So here if you see in your terminal, you will get the 10. So node task I have to say. I got 10. Now once the execution of this function is done, once the execution of this function is finished, then internally what JavaScript engine will do, it will destroy this lexical environment. Nothing but that data structure it will remove. So when that data structure is removed, in that data structure, whatever variables you defined, that variables are also removed from the memory. They are removed from the memory. So once the execution of your program is done, then lexical environment will be removed. It will be destroyed. And whatever variables information are present, those variables are also removed from the memory. Those data is removed from the memory. Now suppose this is case 1. Okay, I'm just commenting this so that you can have this information. I'm adding here case 1. This is our case 1. Now let's take case 2. Okay. Let's take now case 2. Now let's assume that I have here one function parent, and inside that I am creating one more function child. Now in parent function I am creating one variable where x equals to 10. In child I am creating one variable where y equals to 20. And now here I am doing console.log of x comma y. I am doing console.log of x comma y. And here I am calling my child function like this. And outside I will call here parent function. Okay, see, understand what I have done? I created one parent function. In that I created one variable. I created one child function. And then I am calling that child function. In child function, just one variable, one console.log statement. Apart from that, nothing else. Now, whenever I call my parent function, one lexical environment will be created for the parent. So this is the lexical environment for parent. Okay, understand slowly. Lexical environment will be created for parent. In that, it will maintain first its parent information. So x information it will maintain. X equals to 10. Then it will check to this parent function, do you have any other parent? We don't have. Anything is in global, nothing is present in the global. So nothing it will do. Then what we are doing? We are calling here child function. So whenever we call the child function, now JavaScript engine will create one lexical environment for child function also. Now in lexical environment, what it will maintain? First, it will maintain the information of its variable. Then it will maintain the information of its parent variables also. It will maintain the reference of its parent variable, that is x. So reference of x it will maintain. Now in global, you don't have anything. You don't have anything. Here I have commented all this. So all these are not considered. That's it. Now what you are doing? you are calling console.log. So in console.log, it will check, do you have x? Yes, you have the reference of x. Where it is referring? It is referring to this particular environment. So it will pick this 10 and it will print that in the terminal. Then y. Y is present in its own scope only. So it will access this y value, it will print in the terminal. And once the execution of child function is done, then it will destroy this part. After that, you are finishing the execution of parental. So when you finish execution of parent, it will destroy parent lexical scope also. Up to here, no problem. Now let's assume that I have case 3. Now this case 3 is very important. Little bit code I will change. Now see here, same code I am pasting. I have here parent function. I have here a variable which I have defined directly in my parent function. I have here my inner function. And now I don't want to call this inner function. I'm not calling here. Instead of calling, I am returning that inner function from here. I am returning my inner function. I'm just returning it. I'm not calling. I'm returning this inner function now. It means whenever I call my parent function, it will return this child function. It will return child function. So whenever I call my parent function, then parent lexical environment will be created. Parent lexical environment is created. In that, parent variable information is maintained. This is parent lexical environment. Now, when lexical environment will be created? Whenever function is called. Now we are not calling child function. So it will not create the lexical environment of child. We have called parent function. So parent lexical environment is created. Now whenever we call parent, it is returning one child function. So if it is returning, we can hold in one variable. Child function. I created one variable called child function, and inside this variable, now I am holding this entire function. I am storing in this variable because we are just returning it. Now here, the execution of parent function is finished. Right now we discussed whenever the execution will finish, that lexical environment will be destroyed. But right now here, lexical environment will not be destroyed. Why it is not destroyed? Because this child function is not called yet. This child function is not called yet. That is the reason it will hold the destroying process of this parent function lexical environment. Means your JavaScript engine will not destroy this environment. Now here you are going to call child function. So whenever you call child function, now the lexical environment of child function will be created. So if you see, the execution of parent function is done, but still it is holding the lexical environment of parent. It is not destroying it. Now lexical environment of child is created. Now what it will do? It will maintain its own variable. Whatever y value we have given here, 20, plus it will maintain the information of its parent function. So the parent function for this child is parent only. So it will maintain this x reference also, reference of x. So in the child lexical environment, the reference of x is maintained. That is the reason the lexical environment of parent is not destroyed yet. Now here we are going to do x comma y. So whenever we do x comma y, here we have x information, so 10 will be printed. We have y information, so y value will also be printed. Now see here, if I run, here I got same 10, 20. Now once the execution of child function is done, then it will destroy this lexical environment. And afterwards, it will destroy parent lexical environment also. So here, the point what we have to understand is, even after finishing the execution of parent function, the lexical environment of parent is not destroyed. Why? Because in the child function, we are using the variable of x. Means this child function lexical environment is maintaining the scope of parent function. And this process of maintaining parent function scope is called closures, This process is called closure. Which process? Even after finishing the execution of parent function, the lexical environment is not destroyed. Why? Because this child function or child lexical environment is still maintaining the parent lexical environment information. This X information is available here. That is the reason it is not destroyed. Now this process we call as a closures. So closure is a technique of maintaining current environment information plus parent lexical environment information. That is what we call as a closure. So to understand these closures, first we have to understand lexical environment. To understand that lexical environment, first we need to understand lexical scope. To understand lexical scope, first you have to understand global function and block scope. All are interrelated. This is what closures. Closures is nothing but inner function. This inner function is binding, means it is holding. This inner function is holding the scope of its own plus the scope of parent element. That is why we call as a closure. This is how the name came, closure. This is the concept of closures. So when you develop applications here, food ordering application, the major application we are going to develop. Now, if you showcase that application in your interviews, 100% they are going to test your knowledge on these concepts. They will ask, can you tell me in your application how you have used closures? Can you explain me a little bit about closures? So right now we just learned what is closure, how it is working internally. But when we develop our application, we have to find one use case where we have used closure. That use case we have to tell. So in my application, this is the part where I have used closures. Why you have used, that also we have to explain them. If you are able to explain, it means you have a knowledge, you have practical knowledge. If you can't explain, means you never developed application, you never used that concept, so you don't have practical experience. That is how experience is counted. Okay. Yeah. So today that's all, guys. I think things were a little bit heavy. So as a fresher, you guys have to go through this recording one more time. Whatever examples I have done, you have to try this example. By writing this code, you have to analyze what you are doing, how you are understanding that concept. So in this way, if you practice, if you revise, then things will become very clear. So when you attend live session, you will understand 60%. 100% no one can understand when you listen first time any concept. 60% you will understand. Now when you go and watch recording, when you go and practice by your own, when you try to analyze, then that remaining 40% you will understand. In that way, 100% things will become clear. And to keep that concept in your mind, you have to keep revising. You have to keep revising all these concepts. So after 1 week, you have to ask yourself, did you remember what is lexical scope? What is lexical environment? What is closures? At that time, if you feel that you forgot, then just go back and revise it. So the more you revise, the more you practice, that much you will be able to remember the things. That much strongly you will be able to remember the things. Okay. Yeah. So that's all guys from my end for today's session. Now, remaining things we can discuss in tomorrow's session. If anyone have any doubt, they can unmute themselves and they can ask. In case if you don't have any doubts, yeah, you can leave and let's connect tomorrow at same time, guys. Okay, from our classes will be at 8 p.m. guys, from now. From now, our classes will be at 8 p.m. Yeah, if anyone have any doubts, they can unmute themselves and they can ask. In case if you don't have any doubts, yeah, you can leave. Let's connect tomorrow at 8 p.m.